Hello and welcome to SudoKanard. I've had some requests to do more videos in English. Well, obviously, there's a larger audience for English language, I guess. And I've had some requests to do more Kakuro, and especially Kakuro from the website Grandmaster Puzzles. So ask and you shall receive. So I do Kropki Kakuro by Serkan Yürekli from Grandmaster Puzzles, and at the time I'm shooting this video, I'm not sure, I'm producing this video, this puzzle is quite recent. So what is it? So it's a Kakuro, which means that you have to place digits from 1 to 9 in every cell. I mean white cell, not the blackened cells. And in every run, in every set of consecutive cells between black cells or between a black cell and the border, all digits must be different. So these have to be different, these have to be different, these have to be different, but there may be repeated digits between this and this, and actually there must be, but actually it's permitted. Now, the numbers you see here are the sums of all digits in the row or the column. Well, not the whole column, but the set of consecutive cells. So 15 is the sum of these 5 digits, and 11 is the sum of these 3 digits. So that's the rules of Kakuro alone. Now this is Kropki Kakuro, and in all those logic puzzles, Kropki means that whenever you have a black dot between 2 cells, then one of the 2 digits is twice the other. So it could be 6 and 3, or 6 and 3 in reverse order, or 1 and 2, and there are not so many possibilities, but I'll come to that during the solve. And whenever you see a white dot, it means that both digits are consecutive, so it could be 7 or 9. Well, couldn't be a 9 for a sum of 6, but that's to put it simply. So this could, I don't know, could be 6 or 5, so consecutive digits. And whenever you don't have a dot between 2 cells, it means that none of the above apply. So these 2 digits cannot be consecutive, and none of them is twice the other. And I think that's all there is to know. So obviously I put a link in the description to the puzzle, to the website, so you can search, you can try to solve this puzzle before watching me struggle. Now about these. On the website Grandmaster Puzzles, there is always this. That's an indication of the usual time. This is to grade yourself. If you're capable of solving this in around 4 minutes and a half, then you're a grandmaster. And kudos to you. And around 7 minutes is the master title, and twice the time of a master is an expert. Well, I intend to be some kind of expert, but I'm not sure I can solve this under 14 minutes. And I think it's time to start. And first thing, black dots mean that one digit is twice the other. And there are not so many possibilities. It can be actually 1 and 2, 2 and 4, 3 and 6, 4 and 8. These are the only possibilities. One consequence of this is that when you have these three black dots in a row, then it can only be 1, 2, 4 or 2, 4, 8 in some order. But now, here is a sum of 12. 1 plus 2 plus 4 yields a sum of 7. 2, 4, and 8 yield a sum of 14. And this is too much for a sum of 12. So these digits are 1, 2, and 5 in some order. 2 is in the middle, obviously. And these are 1, 4, 4, and 1. And this 13 will help us disambiguate. Now, these add up to 7, so this is a 5. Well, I think this is manageable. If we put a 1, we must have a sum of 12, which may be achieved with 4 and 8. So that's promising. If we put a 4, we need a sum of 9, which may be achieved with 3 and 6. Oh, that's spicy. So how do we disambiguate? Well, I said if this is a 1, let's try it down there. If this is a 1 and this is a 2, then these have to be 4 and 8 in some order. Let's try and see. And then this, so these have to be consecutive digits. But I can't put a 3 in here because these two would be next to a consecutive digit, and there is no white dot here, so that's not possible. But 5 would be possible. And now 7 and 9 both look possible. But I don't see how we can disambiguate. Maybe I did miss some special rule. I did not. Oh. What am I missing? And if I put 4 and 8 in reverse order. Oh, I had missed something. I had missed some logic. Next to the 5 can't be a 4 because there is no white dot here. So this can't be a 4, this can't be a 1. That's why all this is actually irrelevant. Now we know that these digits must add up to 9. They have to be 3 and 6, but 3 can't be next to the 4 because there is no white dot. So this is a 3, this 6, this is a 3. Now these must be consecutive, but 2 is unavailable, so this has to be a 4. And I can't put a 5 in here because there would have to be a white dot, so this is a 7. Okay, much better. Now, let's talk about this 15. 15 as a sum of 5 different digits is actually the sum of 1 to 5. The digits must be 1, 2, 3, and 4. Now we know that these are either 1 and 2 or 2 and 4. And this cannot be a 4 because there's no white dots. I'm not sure that's enough to resolve this. So I'll keep it there for the time being. Let's have a look elsewhere. This 6 is restricted. Actually, 6 is the sum 1 plus 2 plus 3. So that's the three smallest digits. So they must be in here, 1, 2, and 3. And those must be consecutive, so they are 1 or 2, 1 and 2, or 2 and 3. So there's a 2 in here, but I can't put the 2 in here because this one would be 1 and 3, and there should be a dot in this case. So 2 is actually here. So this is 1 or 3, and this is the other. So I synchronize them, sort of, in this way. Now there's a black dot. So 1 should come with a 2, and 3 should come with a 6, and that's the other way here. Now this must be a neighbor digit, so that should be 1 or 3. Don't know which one yet. And we don't have the sum here. We don't have the sum here. Sorry, we do have the sum here. Now there's something nice in here. I can't quite figure out. Oh, yes, I can. 9 as the sum of 3 consecutive digits must be 4 and 5. So there must be 4 and 5 in some order. Now, if this is a 4, then this should be a 3 or a 5. And these should add up to 16. So let's see. 3, 4 would come with a 9. And then this would be 8, 7. No issue there. No issue there. So that's a possibility. If I put a 5 in here, now that's 7. And these ones should be consecutive, but not those ones. So this should be an 8 and then a 9. No issue there either. So 4 is all right. Let's try 5. 5 and 4. So now this should be 6 or 7. Let's say it's a 6. Then to complete to 16 we need another 5, and 5 repeats. That's broken. So it should be a 4. And if it's a 4, then we need a 7 here. And those should be consecutive. This could not be an 8 because we would need a black dot in here. And we don't have a black dot here. So it could not be an 8. So it should be a 6 and a 5. And actually, I'm not sure this is possible. Oh no, it's not possible. I'll tell you why. Let's say I put a 6 in here and a 4 there. Now we have a sum of 10, and we must reach 30. And how do we make 30 with these 3 digits? Well, with a maximum of 3, 8, and 9, that's 20. So that's the only possibility. 3, 8, and 9 in some order, but if this had to be 8 or 9, we would require a white dot in here. So this is not possible, so 5, 4 is not possible. Well, that was not straightforward logic, I admit. Now we say that both possibilities were to be considered, so we could have either 5 or 3 there. Assuming this is a 5, we now have a 7 here, and this can only be 8 or 9, and I say because a 6 would break the puzzles as there is no white dot in here. If this is a 3, we now have a 9, which gives another 8 here, and 7 here. So in both cases, we have 7, 8, 9 triple here. And these 3 digits now must add up to 9, as this is 24 in all instances of the puzzle. There's probably something to be said about this, so I'll come to this later. Let's try and see what happens, how we can have a sum of 9 in here with this black dot. Well, 4 and 8 would break, would be, well, there's no 8 actually, but 3 and 6 would break because this would make 33 without this digit. So we have a sum greater than 33. So it must be 1 and 2 or 2 and 4. 1 and 2 would be completed by a 6. 2 and 4 would be completed to have a sum of 9 by 3, but this would not be possible because 2 or 4 here next to a 3 would need a white dot between those cells. So 2 and 4 is not possible. Those have to be 2 and 1, and this is a 6, and this 6 resolves this ambiguity because 6 can't be next to a 7 without a white dot. So this is a 9, this is a 7, this is a 5. Oh, and now this 5 will be helpful for this. Well, at least I hope so. So let's have a look at this 15 clue. So we need another 10. If this is 6 and 3, then this has to be a 1, in which case this is a 3. If these are 2 and 1, that's a total of 8, and we need another 7 in here. But let's have a closer look to this one. If this is a 1, then we have a 3, that's 4, 9, 17, and now we would need 13. Well, that's not a digit, so this one is impossible. And let's remove all that I had left on the left. So now this is a 7. Those 3 digits add up to 20, so these ones must add up to 10. But these 3 would produce a 7, which is not available, so this is a 1, and now we have a 9 in here, which makes 30. That's nice. We solved this part well. I'm already well over the 14-minute mark, so I'm probably not that much of an expert. Let's have a look at this cell, something I might have done before. Oh no, this was solved very recently. So now this must be 5 or 7 because of the white dot, but if we put a 7, that's 13, 15, and we need another 3 with those 2 cells. But the only way you can have a sum of 3 is with 1 and 2 is not available. So that's not a 7, that's a 5. And we now have 13, we need another 5. 2 and 3 is not possible because of these 2. That's 1 and 4. But 4 can't be next to the 5 because there is no white dot. So this is 4 here and 1 there. And now this is 2. This is 1 or 3. But we need another 1 or 3 here. But it can't be a 3 because it is next to the 4 without a white dot. So this is a 1. This is a 3. So I was right about being patient about this. Next is this 22, I think, because there's only one way to make 22 out of 6 different digits. And I know this because I've been practicing Kakuro for ages. at least 20 years, I think. So I know my decompositions. And if you don't know them very well, what I would advise is to have a chart. You can find Kakuro charts, Kakuro cheat sheets. You can find them on the web. So that's easy. Well, I was saying the only way to have 22 as the sum of 6 different digits is 1, 2, 3, 4, 5, and 7. And we already have 1, 2, and 5, so we need now 3, 4, and 7. And we need here 2 consecutive digits. So these have to be 3 and 4. And this is a 7. Now I can't put the 4 next to the 5 because there's no white dot here. So that's 3 here and 4 there. And where do I look now? I think this is a nice place to look. Let's recap what I said over there. 3 consecutive, no, I should say 2 consecutive black dots mean 1, 2, and 4, or 2, 4, and 8. These add up to 7, and this would require a 12 in this, so this is not possible. So this is 2, 4, and 8 in some order, which adds up to 14, so that's a 5. We have a 4 in here, and 2 and 8 in some order. Now, this is 8, so we need a 1 and a 3, but 3 can't go next to the 4, so that's 3, 1, consecutive to 1 must be a 2, so this is an 8, this is a 2, and this has to be a 4. That's the only way to fulfill both dots. And something you must notice is that between 1 and 2, either circles, either dots fit. Those are, well, 2 is twice 1. I'm not sure it's something that you say in English, but doesn't matter. I'm sure you've understood me. And 1 and 2 are consecutive, so both digits are okay for 1 and 2. Both kinds of dots are okay for 1 and 2. Where do we look next? This 28 is nice because there are only 2 ways of having 28 as the sum of 4 different digits, and these are 9, 8, 7, and 4, 9, 8, 6, and 5. And now, between those 2 decompositions, only one can fulfill a black dot. That's with 8 and 4. So these are 8 and 4. And these are 7 and 9. But knowing that this is 7 and 9, and these 2 digits are not consecutive, this cannot be an 8. So this is an 8. This is a 4. And these are 7 and 9. But now there's this 23. And there is only one way to have 23 as the sum of 3 different digits, and it's 9, 8, and 6. So no 7 here. So this is a 9, this is an 8, this is a 6, this is a 7. Those have to be consecutive. 7 is not available, so this is a 9. This can't be a 7, so this is a 5, and this is a 4. Good progress. I like it. That's a total of 16. We need another 12 with this black dot in the middle. We can't use 4 or 6, so they have to be 1 and 2, and this one tells us that this is 2, this is 1, and this is 9 to complete to 12 and to 27. All right. This 24 attracts my eyes. We have 8 and 7, that's 15. We need another 9 with these 3 digits. Something interesting, how can we have 9 as the sum of 3 different digits? Well, there are 1, 2, and 6, 1, 3, and 5, but this one is not available because we need 2 consecutive digits, so this can't be the right decompositions. And there is 2, 3, and 4. So one of those applies here. If this is 1, 2, and 6, you see that 6 can't go here nor there because there are no white dots around the 7, so 6 should go there. But now we should have a 5, and that's not possible. So 1, 2, and 6 is not the answer. It's 2, 3, and 4 in some order. Well, 4 can't go here because that would require a black dot on here. So this has to be 2 or 3. Let's have a look. If this is a 2, then this should be a 1 or a 4, but not a 4 obviously. So this should be a 1, and to complete to 11, this should be an 8. But the 8 would break the puzzle with the 7, as there is no white dot in here. So this is not a 2, that's a 3. And now that's a 6, the double, and a 2 to complete to 11. 4 and 6, this has to be a 5. This should be a 4 or a 6, but it can't be a 4 because there's no black dot. As you might have noticed, this no dot rule is very, very important. It's I dare say it's the most important rule in the game, actually. This has to be a 2 or a 4, but it can't be a 4 because of the no dot rule. So that's a 2. We now have a partial sum of 1, 3, 8, 14. We need another 15, so these have to be 2 consecutive digits adding up to 15. Those have to be 7 and 8. I can't put 8 next to 4 without a black dot, so that's 7 and 8. And we're supposed to complete this. Oh. As of now, the sum is 3, 11, 14. We need another 10. 10 without using 1, 2, or 3 is 4 and 6. 4 can't go next to the 2, so that's 4 and 6 this way. Very nice. That's very, very expertly put. That's a very nicely set puzzles, I must say. Now we only need those, and we need to disambiguate this, and we need those. Oh, this 24. That's 11, 20, so that's a 4. This should be 2 or 8. Let's have a look. 2 or 8. Now with the 2, this has to be 1 or 3. But that's not possible, because with the 3, we have a total of 14, and it requires 11 in this. It's not possible, and with the 1, it's even worse. So that's an 8. And what do we put in the remaining 2 cells? So this is 7 or 9, and let's have a look. 4, 8. And 9 and 5 make 17. Oh, 17. Okay, so 9 is too much. It would make 26. So with 7, that's 24, and this requires a 1. And now this is a 2, this is a 1, this is disambiguated. We have a sum of 14 with these 4 digits. We need another 8, and it can only be done with 3 and 5, and 3 can't go next to the 2. So that's 3 and 5. And this wraps up the solve of this very nice Kropki Kakuro by Serkan Yürekli. And I think it's the right moment to thank all people who contribute to all the logic puzzle blogs everywhere on the web. We have plenty of resources to have fun and to stimulate our brains and everything. And well, let's stop with all this nonsense. Thank you for watching this video, and see you soon on SudoKanard.